Hello everyone.
My name is Krishna Prasad. Today we are going to discuss about a topic of involvement of robotization in manufacturing industry. Okay. So again start with what exactly a manufacturing process. So like already told you, manufacturing is nothing but manufacturing is a conversion of raw material to end output. It's nothing but a manufacturing process. Manufacturing process is nothing but, so if you are taking a raw material and we are converting that raw material which have different type of machines and different type of process, and we are converting that to your desired output. That is nothing but manufacturing process. Whether the raw material may be a complete raw material, which means a powder raw material or a block or whatever it may be, or a semi-finished operation or a semi-finished product, is nothing but a raw material. And conversion of that semi-finished or raw material to your end product is nothing but a manufacturing process. So now, what is a manufacturing process here? So how the manufacturing process evolved from starting to ending? So that can be different. That can be explained in this session. So previously we used to work on a conventional missions. So what exactly conventional mission? Conventional is nothing but the mission which can be operated manually, okay, on its own manually. So if at all we want to prepare a hole, that can be done derived by the levers. If at all we want to do some lathe operation, that can be performed by the manual feed or manual, everything is on the manual one. What will be happen with the technologies and with the innovations, that conventional missions can be upgraded with NC missions. What exactly the NC missions is? A numerical control missions. In the numerical control missions, again with the help of these codings, and they will be generated, they will be prepared on a punching tapes, and they will be given to these NC missions, and the program was completely performed in this task. Okay, and with this type, what will be happen? So we are getting some desired output. So this is NC missions, and the improvement doesn't stop over there. And after the NC missions, the CNC comes into role. So what exactly the CNC mission? Computer numerical control. So which means integration of computer to the numerical control missions or the normal missions. Which means here there will be no magnet tapes, no nothing. So only there is a special language for the CNC missions, completely G codes and M codes. So with the help of G codes and M codes, you can do what are the program. So we can derive exactly what exactly we need. So we can perform any complex parts also with the help of CNC. So with the CNC technology, we are getting some random high, okay, some high output with this CNC technology. Okay, and there the innovation or improvements doesn't stops. And after CNC technology, the DNC comes into place. What exactly the DNC is? DNC is nothing but direct numerical control, which means collaborating all the CNC missions or integrating all the CNC missions with a master computer, with a master server system. So what will be happen? I am having a 10 number of CNC missions, and I can perform each and different operations by controlling through a common server system, that is called as a DNC. So we can store all the data, we can store all the program. So if I am having 1,000 programs, and I can run 1,000 programs in 1,000 missions simultaneously by the help of DNCs. With this, what will be happen? Again, my production rate will be increased, and after that, so there the production rate, there the innovation doesn't stops. Again, then the conveyors comes into place, or automation comes into place. What exactly the automation is? Automation is nothing but automation is a process that substitutes the human efforts with mechanical components. Is nothing but automation. So best example of automation are conveyors, automated guided vehicles, some sensors, actuators. These are nothing but there are some more, etc. will be there are many more. So there are some of the examples which I have enclosed here. So with this type of automation, what will be happen? So with the involvement of automation, with the CNC machines or with the machine on the job floor, now my production rate is completely increased. Okay, and compared to the previous one, if at all I want some desired X output, I am reaching up to some M level or N level with the level of automation. But after reaching the automation levels also, the industry won't stop its innovation. Now they have involved robotics. Robotics is the concept, which means where it is completely replica of human. Automation is a replica of human control, human paths, whereas robotics is a replica of human. Okay, got it? So I am telling you again, automation is nothing but automation is a replica of human effort. If at all a human is carrying one part from station 1 to station 2, that part is nothing but can be automated. That path can be automated by using conveyors. That path is automation. If at all a human is working on a mission, Okay, he is putting the mission, he is putting the workpiece in the bench wise, in the mission wise, and he is running the program. that part that part of the human effort can be replaced by robotics. Okay, now understand the difference between robotics as well as automation. Automation is nothing but it is a missionized concept, missionized transport concept, whereas robotics is a substitute for human efforts. Now with the involvement of human effort, what will be happen? Again my production rate was completely increased because of the involvement of human, because of the involvement of automatics, because of the involvement of CNCs. The combination of all things, my production rate of the industry was greater when compared to the previous one, and I'm getting a flexible parts will be, I'm getting flexible parts, I'm getting flexible, higher repeatability is there, I'm getting high quality products will be observed because of the involvement of all these concepts. If at all, see, let us take an example. If at all my industry is having CNC machines and robotics without the involvement of automation, what will be happen? Okay, the robots can do the human efforts, but not this traveling paths. It cannot travel. The robot can be fixed. It can't travel from one place to another place. So because of this constraint, automation is also needed as well as robotic also needed. Okay, let us take this example. So I am implementing, my plant is having all the CNC machine, all the automation, but not robotics. So I want to perform an operation which can be performed by a human without the involvement of human. So is there any method? No, automation cannot be performed here. Why? Because human can be the replacement of human only. So he is the one you need to do the job. So there is no any automated equipment is there to perform the operation. But we can perform that operation by the help of robot. We can put this some robot here. We can put some pick and place robot here, and we can put that. What will happen? That pick and place robot will pick the object from conveyor and it will put it in this workstation. So automatically the operation will perform. And again, so what will be happen? Once the output is ready, the robot will come and pick that part and place it in the conveyor. The conveyor will do its part. So here automation and robotics are both of the two machine for industry for getting higher production rates, for getting, if it is a fixed automation industry, which means the industry is running completely, okay, with some 1000 outputs per day or 24/7 working plant is there. It's like a continuously working plant with some desired output. For that plant, the definitely need of automation and robotics will be definitely needed. Okay, so this is what the concept of robotics. So now I will clearly explain you what exactly the robotics is. Robotics is a concept that can be measured and taken the cause of process carried out on its own, okay, by the help of program. So if at all you are giving a program and you can ask it to run on its own, yes, it can run for number of cycles also, but we need to give the repetitions. If at all I want to prepare a robot and I will give some 1000 repetitions, up to 1000 repetitions, it will do its on duty. So if it is a pick and place application, it will perform up to 1000 pick and place applications. Once the given time is over, means repetition is over, it will come into its own position. Why? Because it has completed its own task here. So now understand what exactly the robotics is. Robotics is a term that applied to all the measures taken to automate a path, okay, to automate a path with the given conditions. That is nothing but a robotics. Robotics is a technology that concerned with the operation of mechanical, electronic, computer based and program based operation and controls. Okay, so if I want to run a robot, so all I need is first we definitely need a machine. So to put that, okay, that will be second part. So now if I want to put that robotics into an working, then I need is a mechanical components will be needed, electronic components will be needed, computer based software is also needed to give that operation into its own. So with that help of robotics concept, we can increase the productivity to higher levels. Now I am telling you where exactly this robotics will be used again. So if at all my plant is a continuous plant, and coming to the concept, if at all I want to implement this robotics, okay, in the industry, what are the things I needed? So I definitely need a process. If it is a flexible manufacturing industry, so it should be a continuous running. So I need to get 1000 outputs or 10,000 outputs per day. For the type of process, what will be happen? The machines will be running continuously and the automated parts are continuously running. But what will be happen here? So the workers are running continuously. So worker is a human being, so he is having his own things, so he need to work for some time only, and he is having his constraints to go into the mission. or to put the machine or to carry that part from one place to another place. If at all I am using some welding application, okay, let us take the welding application. So after finishing welding, what will happen? The workpiece will be heated. So if the worker is trying to catch that workpiece, what will be happen? It will be like a medical breach will be there, and it will be some injuries will be observed to the workers at that point of time. So if at all I put some robot over there, so and I am giving some grippers to the robot, metal grippers, so what will be happen? You can directly pick that object and place it somewhere. Why? Because robot doesn't have any injuries or any these type of factors. Accidents will be doesn't happen to the robots, where humans can get the accidents. Okay, so this is the main thing. And second other thing, so where exactly this robot plays a crucial role? If my operation is continuously, if the repeatability is there, if at all I want to like I'm telling the example, if at all I want to weld a part, okay, which is having small in length, then what will be happen? So it is difficult to put that object in a vise, or it is difficult to put that object or hold that object with the hands. Then only what will be happen? Then I'll put some two robots over there. So one robot will catch the two pieces over there, and some other robot will do the operation. That will be performed perfectly. So without the help of human efforts also. And this is one of the factor. And if at all this is a micro application. If at all I'm talking about the large application, huge application, my car body is there, my heavy body is there, and I want to weld that complete body in a single take. If at all my human efforts, what would be happen? Like I already told you, if I'm having an application, huge application, if I want to weld a complete car body, then what will happen? It is difficult for a worker to reach the complete part. Whereas if I program that part to the industry, to directly a robot, industrial robot, then what will happen? Completely the industrial robot will reach from starting to ending continuously without any pause will be there, and automatically so it will travel all the way. That will be beneficiary one. So these are the different type of applications will be there. So the robotics is a concept where it can be replaced of human efforts, where we can get the maximum product will be there. And if the repeatability is there the robotics is there. So some of the components for robots are like, we can use some applications like welding application. We can use it in the welding application. If at all it is having underwater welding is there, or nano welding is there, micro welding is there, large welding is there, we can use that continuously. If that operation is repeatably, then we can use that also. Even for material handling, if at all I want to pick and place some object from one place to another place continuously in a mission, let us take an example for if it is like a mission output to mission input, then we can perform that task also continuously. And while coming to the dispensing and material handling, packaging, so packaging is a continuous effort where we can directly put the cardboard and we can fold it. That can be done by the completely robots with the help of some humans. And some cutting section, if at all I want to cut some parts, some spray cutting, gas welding, gas cutting, or normal cutting is there also we can use these robots. Why? Because it's a continuous path in a fixed automation. So what will be happen? The missions are running continuously and the workpieces are coming continuously. So the motion, these parts need to be robotized for getting higher outputs. And what exactly we are getting with the help of robotization? So that is the main thing. So why? Because we are implementing automation, CNCs, everything in the industry. By implementing those missions, we are getting some output. By what is that output which you are getting by implementing this robotics into industry? So we are getting high precision and high accuracy. That is the main thing. Here it is a continuous repeatability operation. So in repeatability operation, if you are getting higher accuracy by using this, then that will be increasing the higher production rates. And second one is production rate. So again we are discussing about production rates. With these type of higher repeatability, higher accuracy and higher work production, higher work rates, we will get the production rate as increased with this repeatability. Now again, robots won't precise to this complete closed environment like welding, material handling, pick and place, dispensing. It will be into everywhere. We can directly involve some cameras or sensors to this robotic parts, robotic grippers. So automatically what will happen? So if at all application is there, pick and place application is there, it should need to carry only square part, but a circular part is come. So what will be happen? Automatically the grippers will sense the object. If at all the object is perfect at this design, then only it will pick. Otherwise what will be happen? It will pass a signal to some other source, or it will come into home position because of its program generated. and some other sense like I already discussed, sensors, cameras. If I want to record the program, if it for a no hazardous program or hazardous zone, then only it will be performed by this one. If at all I want to do a spray paint, which will be a difficult task for humans to enter into that region because of this hazardous in nature. So at that type of applications also we can directly use these robots for doing all the applications. And directly robot can sense if I want to inspect the objects. If at all I have prepared a complex part and I want to inspect that part with the design, so it is a replacement of CMM also. Directly I can give connect a probe to the hand gripper and hand of the robot, and directly I can check the output of the machine for checking this output or inspecting the output with the designed one. So we can use that aspect also. And all the way for robotics, again everything is having pros and cons. What exactly this robot having benefits, what are the advantages and what are the disadvantages of robot. So let's discuss about the benefits of robot. We are getting higher productivity and higher flexibility, repeatability is more, and we are getting more desired outputs, and everything is there. So now what are the disadvantages? Everything is having its own disadvantages. What are the disadvantages of robotics? It is higher to install, it needs more cost to install first of all. And the software, we need to learn the software continuously. If at all a small error in the program, that will collide the robot with the machine parts, that also need to be worried, that also need to be checked continuously. The collision, we call it as a collision error. So if the robot is free from collision error, then it will run perfectly. And second one is controller settings. We need to monitor the controller settings continuously. Why? Because the robot is completely dependent upon the controller. If at all a small change in the controller, then the robot movement will be changed. Continuous home positioning or commissioning of robot will be continuously need to be maintained. Why? Because if at all the application is a pick and place application, if the weight of the object is more, then what will happen? The robot will work on degrees of freedom with angle. So if at all my robot is picking some weight and it is moving all the way, then what will happen? Maybe some errors will be raised, some gears will be measured after 1 year or 2 years or maybe 3 years or maybe 10 years. Then so there will be errors will be there. We need to commission that continuously. We need to check the errors. So whether it is running perfectly or not, whether it is running with the degrees or not, that need to be verified with the help of commissioning. And one more thing, the like we already completed with the disadvantages, we're coming to the advantages. One of the main advantages of this robotics is it should run around the clock. There will be no any delays, there will be no any breaks will be there for this machine. We can run it continuously for 24/7. But all it needs is it needs separate server for there, and it needs separate cooling system, and everything should be provided for this robot to run on its own. This is the first thing. And second thing, we can perform any type of operation, like we already discussed, spray, welding application, pick and place application, material handling, painting, dispensing, packing, and everything. We can perform any type of operation. Even we can implement this robot where if we want to replace any human, we can directly replace it. If I want to implement 5 different robots to hold an object and do the welding operation, that also we can be performed. But we need to give the simultaneous program, collaborated program for all the missions, then only we can perform it. And now how exactly this robot will run, that is the main thing. So this robot will be, the main structure of the robot will come under the base. Okay, that is the main thing. The base needs to be fixed or fabricated to the ground, then only it will be rigid. It won't move from the in the middle of the operations. That is the main thing. And again on that base will be, pedestal will be there, and arms will be there, and these will be movable arms. If it is a rotary, it should be rotating in degrees. If it is a linear robot, then it should be moved on this to and from motions. But all the robots should having some maximum radius will be there. Up to some maximum radius only it will move, other than that it won't move. Again, this robot is having some positive and negative values, which means the reach values. So it should up to reach only up to some extent only, otherwise what will happen? It will be correlated with own or some other parts. So it should having its own values, that also need to be understand. And after the base, pedestal and arms, there should be some 2 more arms will be there, one for holding gripper and one for gripper operation. that need to also be performed. So one arm is there to hold the gripper and to rotate the gripper. So to hold the gripper here means, so if at all you want to hold a welding gun, that should be catched by the grippers only. If at all you want to put some object, pick and place object, if it is a cylindrical one, then that gripper should be ready to take that object. The grippers will be anyway, like it should be having some different like shapes. Based upon the end application, you can choose the grippers. If at all my application is some inspection, if at all I'm using my robot for some inspection purpose, then instead of gripper I will put some probe, inspection probe over there, and put some that, and I use that probe for operating. Like this painting application, I will put some painting gun for the gripper, and I'll use the operation. So this is how the robot construction working will be there, and all the programs will be directly monitored by the help of controller. And even we can directly do the offline programming for robot. If we are having the control for on own, directly we can prepare on our own. If at all we are having a software like robot expert is there, robcad is there, some other softwares will be there. So no, we are using robot expert. So if we are having robot expert, what will be done? So directly I will create a virtual platform for my robot and for my operation. Then directly I'll measure the robot directly the dimensions of the robot, or I'll directly import the files of the robot from the sites and directly import that in the software and directly put the application. I'll prepare the application and I'll test the application, run the application. I will check the application with collision free, and number of reputations will be there. I will run the application for if at all my robot need to run for 100 cycle times. Okay, I'll run the application virtually in the software. I'll check that any error will be there or not. Why? Because the same operation that will be performed in virtually will be performed in realistic robot without any delays. So if at all I'm getting an error in the virtually, the same error will be get by the robot also. So that need to be first, I need to be clear in virtually. My program is working perfectly, then I need to put that program, I need to copy that program and copy it to the controller, or transfer it to the controller of the robot. Then what will happen? First I need to check that robot whether it is running perfectly or not with the program. So why? Because it's called as initial run. I need to check run. So I need to check it whether after directly putting that robot into operation, if at all some collision will be happened, so it will be a loss. So I need to test on it first before entering into this arena. So I'll test on it. If it is running perfectly, then I'll give the task to the original process. So I'll implement this process in the process. So what will be happening then? The process was continuously run for the given number of cycles, the cycle of repetitions. So automatically it will do its own process. This is how a robot will work. So involvement of robot in a manufacturing industry is quite difficult. Why? Because it should need a completely skilled worker. Without the skilled worker, we can't even handle the robot. So a skilled worker is definitely needed for program, to prepare a program virtually, and a skilled worker definitely needed to run the robot directly. So both are two different persons. One is for virtual, one is for realistic robot run. So both should be needed, and both should be integrated with each other. Why? Because this realistic robot will be integrated with the virtual robot. Then only we will perform the tasks. So the involvement of worker, the involvement of skilled worker was the main criteria in this robotics concept. Okay, with this concept I am concluding that robotics is the emerging topic. It is an emerging topic or increasing topic in the present scenario. So the involvement of robotics, automation, CNC machines in industry will give us the best outputs and higher production rates, with the desired outputs and desired production rates in an industry. So with this topic I am concluding that robotics is a best topic which can work on the future perspective, whether we can run on for academic projects, we can go for industrial projects, we can implement different projects for this industrial section by creating new paths, by creating new roles for industrial robots. So with the help of robots we will definitely increase our production rates higher, and we will get a higher accuracy rate and higher precision by using these robots. Okay, thank you so much.